Hi everyone, I think we are live now. 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 Okay guys, so if you can hear and see me, you can just say yes. If you can hear and see me, you can just say yes. If you can hear and see me, you can just say yes. Hear and see me, you can just say yes. Okay, give me a moment. Okay, give me a moment. Okay, give me a moment. Okay, do you guys still sense the echo? Okay, do you guys still sense the echo? Okay, do you guys still sense the echo? I think it still is there. Let me just fix this up. It still is there. Okay guys, so is the sound better now? You can just give a quick nod. You can say yes if there is no echo. Perfect. Okay, great. We experienced a slight delay because of some echo that we were having, and now we can start the class. So today, interestingly, we have a very good question. It's I would say a hard question of dynamic programming, and in fact it requires one to already have sufficient enough practice in dynamic programming. In fact, when you study dynamic programming, you will hear things like, hey, this question is a one-dimensional DP, this question is a two-dimensional DP, this question is a three-dimensional DP. So this question is a three-dimensional DP. So I think it would really comfort me if I get to know from you that how many of you have already solved some questions on one-dimensional DP. You can just say yes if you have some experience of problem solving in one-dimensional DP. Okay, and how many of you have studied two-dimensional DP? Okay guys, so is the sound better now? You can just give a quick nod. You can say yes if there is no echo. Perfect. Okay, great. Okay. We experienced a slight delay because of some echo that we were having, and now we can start the class. Anyone who also did two-dimensional DP or three-dimensional DP very well? So I'm asking these questions so that I can give you a bit of context around it. Although it won't be possible to talk everything about dynamic programming as it's a huge topic, huge topic. We'll see what we can probably do for that for you guys. Also one more thing, yesterday I recommended you guys to watch some of the videos, some of our very basic videos on YouTube which are there for dynamic programming and recursion. Could you get some time to watch those? If you have watched those, you will be able to understand a lot of things, because for recursion, for dynamic programming, one of its backbone is recursion actually. Okay, let's read this question first. So this question says that we will be given three integers n, m and k. Okay, super simple. So three integers are your input. And now you have to consider the following algorithm to find maximum element of an array of positive integers. So you have to assume that there is an array which contains positive items. Okay, and now you have to find maximum element from it. And all of us know how to do that, right? We can just write a single for loop and run it from index 0 to index n minus 1, and then we can determine the maximum element of the array. So here also the idea is pretty much the same. I'm just going to highlight the important lines. The first line, as it says, maximum value equals to minus 1. So we always initialize maximum to minus infinity, but here the elements are positive, so we can initialize it to minus 1. And then there is something called as maximum index also, which is also minus 1. We have also initialized search cost equals to 0. Now search cost is the most important variable over here that you guys should focus your attention on. See, this for loop is super simple. No need to use a lot of brain on this. Here all that we are doing is we are comparing the ith element of the array with the maximum value that we have so far. So initially the maximum value that we initialize is minus 1. And of course array of 0 will be greater than that. Why? Because everything in the array is positive. So the moment you see this, you will change your maximum value to array of 0, and you will change your maximum index to 0, and then you will add plus 1 to your search cost. So basically what is happening is that if let's say we had an array that looked like 5, 1, 2, 6, ... then what's going to happen is that the moment you see that you have a 5 which is greater than minus 1, your search cost will be added with plus 1. Okay, in the next iteration of the for loop, your element is 1. Now would your search cost increase for this 1? Do you think that? Yes or no? The answer is no. Why? Because at this point of time your maximum value will be 5, and 1 is not greater than 5. Because 1 is not greater than 5, you will not come inside this if block. And if you do not come inside this if block, you will not add plus 1 to the search cost. As simple as that. Similarly, when you move on to the next iteration at 2, again you will not enter inside the if block. But when you come to this 6, you will see that 6 is greater than your current max, which is 5. And as a consequence, you will enter inside and you will do a search cost plus 1. So basically I would say the value of search cost will be equal to how many times, our max value actually got updated. This is what it will be equal to. So if I have a full-fledged array that let's say looks like this, and we start with max val equals to -1, can you tell me that what will be the value of search cost? Initially the search cost is 0, but when we run this algorithm, what will be the final value of search cost? Okay, so Shivam is saying 3. What do others say? It's absolutely essential to understand the question completely before you can go on to solve it. Okay. Okay, so a lot of you are saying 3, and I believe because you're saying it, you should be right. So if we see here, first time when we see that 5 is greater than -1, we will increase it, right? And we will also change it to 5. Now, here and here it is not going to change, but the moment we come here, we will change it and we will increase it. Similarly, here and here it is not going to change, but here we will change it and we'll change that. So as you noticed, your maximum value got updated here, here, and here. At how many places? 3 places. That's the reason final value of final value of search cost is equals to 3. Correct? Okay, is everyone clear with this thing? That what is search cost and all? Okay, this was just, I would say, the initial part of the story. This is not the actual question. Now, if we come down, you see the question says you should build the array ARR which has following properties. So you have to now build an array which has following properties. The first property is that it has exactly n integers. So this is your input n, and let's say if your n is 11, then the array built by you should have exactly 11 integers. That's the first requirement. The second requirement is that each element of the array should be in between 1 to m. For example, if your m is 10, then each element should be in between 1 to 10, which is the case over here, right? So that's also perfectly okay. The next thing is that after applying the mentioned algorithm to ARR, the value of search cost should be exactly equal to k. We all know what is search cost. We all know how it is computed. So if you really read this line again, maybe twice or thrice, you will understand what it's saying. It's saying that if I were to find out the maximum in this using this algorithm which is written over here, the value of search cost should be exactly equal to k, which is also a part of our input. So basically what we have to do is we have to build an array ARR which has all these 3 properties. Feel free to read them again and again because it is very important to be clear with that. And even remember that, because when you solve the question, when you write the code, you cannot forget them. Okay, now guys, tell me one thing. If let's say this is your input, n is 11, m is 10, and k is 3, is this a valid array? You guys can write yes if you feel it is a valid array, and if you feel it is not a valid array, feel free to write no. Okay, so Shivam is saying it is a valid array. Rachit is also saying that. Okay, let's take a look. So I think yes, because to start with, our max value will be -1. So here max value will be updated. Here also it will be updated. Here also it will be updated. So it has been updated 3 times so far. Now the max value will be equal to 3. Since your max value is equal to 3, will it now ever be updated? The answer is no. It will never be updated. So the value of your search cost will be equal to 3, which is equal to your k. And rest of the rules we have taken care of. We have made sure that we have exactly 11 items here, which was the first rule. And we also have made sure that each element is in between 1 to 10, which is also the case over here. Correct? Okay, but guys, I have a question for you. The question is, what if I rather have a different array? Let's say I have created something like this. Will this be a valid answer? Yes or no? Clearly no. Why? Because your max val will be updated here, 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 and then it will also be updated here. So the search cost will be equal to 4, which is not equals to k. So this is not your valid answer. Now I want you guys to take probably another example, one more example. What if you had something like this? Is this okay? Is this a valid array? Yes, it is a valid array. Because here also, if you take a look, your search cost will be exactly equal to 3. I mean, your max will just be updated here, here, and here. And because after this, all the elements are smaller than equal to 3, which is your maximum value, so they'll never be updated. So this is also a valid array. So guys, this was also a valid array. This is also a valid array. And then I'm sure you guys can think of many, many more other valid arrays. Can you just reply saying yes or no? Can you think of many, many more other valid arrays on your own for the given input? Yeah, all of you can. So there will be so many different sorts of arrays which abides by the given input. So what we have to return is, we have to return the number of ways to build array under the mentioned conditions. Now keep it in your mind that we do not have to print the array. Nobody is asking you to print all the possible arrays. You are just being asked to say that what is the total possible ways. That's it. That's all. And now there is one more addition to it. The question knows that at times there could be so many different ways. I mean, so many ways that it could not even fit inside an integer or long integer. So it says that what you can do is that instead of returning the actual answer, you can return answer modulus this value, which is 10 raised to power 9 plus 7, because we all know that if you take mod with this, the value will be lesser than this, and that way it can fit into an integer. Anyways, this is not that important part. This we will come to later. But this was the most important part, where the question is not demanding you to fetch all the possible arrays, but it is just asking you for the count of how many arrays are possible. How many of you are now crystal clear with the question, the problem statement? Yeah, that's awesome. Okay, now if you look at this input, you can have a look like n was 2, m was 3, and k was 1. So k was 1 and the value of m was 3 and n was 2. See, when n was 2, what does it mean? It means that we just want 2 elements. We just want 2 elements. Now, moreover, the important thing is that we can just have elements from 1 to 3. So our elements can only hail in between 1 to 3. Correct? Now, the important requirement is that the value of k should be 1. The search cost should only be 1. Now guys, tell me one thing. You are going to create a positive array, and to start with, max val is -1, if you haven't forgotten it. To start with, max value is -1. And you are going to create a positive array. So can I say that the search cost will become 1 at the first index itself? No matter what item you have at your first index, that item will be positive. And since it is positive, here itself your search cost will become 1. Are you getting this point? How many of you are getting this point? Right? Now, if you are really understanding what I'm trying to say, I would say that, hey, my first element, it could either be 1, or it could be 2, or it could be, can you say that? 3. Why? Because the value of m is 3. So I am free to have any element in between 1 to 3. Now just answer me one thing. The moment you have put your first element as a positive integer, and given the fact that the value of max val was -1 initially, here at the first index itself, the value of search cost would have become 1. And the k is also 1, so we cannot afford to increase it further. Now tell me one thing. If you have a 1 here, what element would you want to keep here so that the search cost does not further increase? The answer is, I can just have 1 here, because if I put a 2 or 3, in that case it will go up. With the same logic, I can easily say that if I have a 2 here, then how many choices do I have here? Can I put 3? No, because if you put a 3, the value of search cost will become 2. But can I put a 2? Yes. Hey, but can I also put a 1? Yes. Okay, how about here? Here I can say that it could be 3. Can it be 2 also? Think out aloud. Yes. Can it be 1? Yes. So these are the 6 possibilities, and that is exactly what you can see here, and that is the reason answer is 6. So how many of you are clear with this particular input output? Is this making enough sense to everyone who's present over here? Yeah? Okay, awesome. There are a few things that I want you guys to note. This example was a super important example, and this should really ding a bell inside your head if you have followed me on this. See, here what happened was, the moment we chose our first element, then we needed to ensure that the value of k does not go up. That the value, not k, sorry, the value of search score does not go up, right? This was what we wanted to ensure, right? 3 से start करेंगे, then search cost will not be 3. Search cost, you have to keep 1, no? You want to keep a search cost of 1. So what is the search cost for this? Think about it. What is the search cost for this and that? Just think about it. It's all 1, right? Okay. So coming back to my point, the moment you decide your first element, after you have decided your first element, you wanted to ensure that the value of search cost does not go up, because there itself search cost became 1, which was equal to k. Now what did we do to ensure that the value of search cost does not go up? Can you put some hard thoughts to it? So let's say if our first element was 3, what did we decide for our second element so that yes. So how many of you agree with what Cortelia is saying? So we wanted to make sure that our second element is strictly smaller or equal to our maximum element so far. Just think of it. It's not very hard to think, right? See, even in this case, even in this array, if you look at till this point, what is your maximum? Let's say you have brushed this much of the array. What will be your maximum value? Your maximum value will be equal to 3. Now, in this part, everything is strictly smaller than or equal to 3, which was your max so far. That is the reason value of k did not change, did not go up. But on the other hand, if you had a value over here, which was, let's say, greater, in that case, the search cost will go up. So the idea that I want you guys to understand is that, hey, if you have a random array, let's say somebody gave you a random array, let's say this is the random array, and you know that this is your max. Now, as long as all the items happen to be smaller than or equal to your current max, max will not update and search cost will not change. Correct? The moment you get a value which is greater than your max, search cost will update. And now again, from there onwards, as long as you are getting the value which are smaller than or equal to your current max, which is 6, things will not change. And this is a common sense actually, although I am trying to portray it as if it's an observation, but if you correlate, it's a common sense. Don't you think so, guys? How many of you think so? Yes or no? Right? Okay. So tell me one very simple thing. Let's say for this particular input, I already showed you 2 possibilities. Now what I want to do is I want to construct a third possibility where I want 11 elements, but I have just fixed 3 elements for now, 2, 8 and 10. Now tell me one thing, because I have a 2 here, I have a 8 here, I have a 10 here, is it guaranteed that search cost will be at least 3, which is k? Don't you think so? The answer is yes. Why? Because to start with, it will first update here. your max will update here, it will become 2. And then because after 2, somewhere you have an 8 which is greater than 2, so again it will update here. And after 8, somewhere you have 10 which is greater than 8, so again it will update here. Now, in order to ensure that this sequence is a valid sequence whose search cost is equal to 3, can you help me determine these intermittent elements? Can you fill in the blanks? How many of you can fill in these blanks on your own? Just say yes if you can. Yeah? Okay, tell me one thing. What values can come here? What values should come here so that the max does not change further? It should be something which is smaller than or equal to max so far. Look at this line. This is the most important line. What is your max so far? It is 2. So all the values in this zone should be smaller than or equal to 2. So either I can have some 1s or I can have some 2s. So let's say I have a 1 here, and then I have a 2 here, and then I have a 2 here. Now let me tell you, it's just one possibility, but there could be many more possibilities. It could also be 2, 2, 2, 1, 1, 1, 1, 1, 2, 1, 1, 1, 2, 1. There could be so many possibilities, right? Okay. Similarly, now when you come here, your max so far becomes 8. If your max so far becomes 8, can you fill in the blanks here? Can you tell me what are the values that are allowed in this zone? The values that are smaller than or equals to 8, they are allowed. So anything in between 1 to 8 is allowed. So you could have a 4, you could have a 7, correct? Now when you come here, your max so far becomes 10, right? Now in order to ensure that it does not further change, what values can you have here? You can have anything in between 1 to 10 because now your max is 10. So you could have a 1, you could have a 7, you could have a 9. Now just look at it. When you look at it, can you tell me that, hey, this is a valid array for which the value of search cost is exactly equal to the given k? The answer is yes. So what is the most important takeaway from here? Tell me. What is the most important takeaway from this exercise? See, so far everything is just a common sense. There was no element of dynamic programming. I have intentionally taught it this way so that you don't get scared. So you guys feel free to tell me what is your most important takeaway from whatsoever we have done so far. So Cordelia has written something, okay? And others, do you agree with it or do you want to add something on top of it? Okay. The most important takeaway is that if we somehow know the maximum element so far, then this is going to help us a lot. This is going to help us immensely because, see, tell me, what is the maximum so far? If let's say you have brushed this part of the array, what would be the value of maximum so far? I'll just put a pipe here to demarcate. The maximum so far would be 8, correct? Now, if you want to decide what element should come here, and at all the remaining places, let's say you don't know. Now, if you want to decide what element should come here, then you can say that, hey, anything that is in between 1 to 10, because the value of m is 10, so anything that is in between 1 to 10 can come here, right? But the point is that, hey, if you put a value over here which is smaller than or equal to 8, then in that case, will your k change? Will your k change if you put a value over here which is smaller than or equals to 8? The answer is no. Your k will not change. By k I mean, the search cost. Will your search cost change? The answer is no. But if you put a value here which is greater than 8, in that case, will your k change? Yes. In that case, what will be the value of k? The value of k will be k minus 1. So I can say that, hey, you know, at this particular juncture, if somebody asks me that, hey, how many choices do you have for the next element, I would say m choices from 1 to m, which is 10 choices. But I'll also tell him one thing that, hey, you know, if you put a 1 here, or if you put a 2 here, or if you put a 3 here, basically if you put anything in between 1 to 8, in that case, the value of k is not going to change. And now I'll have to make sure that I change the value of k, or the value of search count, the search score in this remaining part. But if I put over here 9, or if I put over here 10, in that case the value of search count will change. It is going to change because now here the maximum value will be updated. So this is an important thing for you guys to understand. Now guys, if you are really looking at it, I would tell you one thing for sure, that in this question, what are the important variables that we have to track? Of course, the first most important variable is the maximum element that we have placed so far. Needless to say, this is the most important variable. Apart from that, what is the next important variable according to you? Yes, the search count, or the search score, search cost. Okay, I'll refer to that as k for now, right? And so what I'll do is I'll start with an initial value of k. Let's say k is 3. And the moment it changes, I'll do k minus minus. For example, I placed a 2 here. Then the value of k will become 3 minus 1, which is 2. Here k will not change, here k will not change, here k will not change, here k will again change. So here k will become 2 minus 1, which is 1. So eventually when k becomes 0, it means that now we are kind of done. So this is how I'm going to track my k. So k is basically equal to the search cost that I have to ensure in my generated sequence. I'm telling it again, k is the search cost that I have to ensure in my generated sequence. Okay, and this k will change dynamically depending upon the element that you have chosen. Okay, the next most trivial variable to track is n. N is the size of the sequence that you are trying to build. So to start with, you will try to build a sequence of size 11. But as you are putting the elements, the remaining size will decrease. So let's say if you have put 2 over here, then now your leftover workspace is of size 11 minus 1, which is 10. If you put one more element here, then it will become 10 minus 1, which is 9. So like you can see that in this particular stage, I just have 1, 2, 3, 4, 5 more slots left. So I would say that at this particular point, the value of n is 5, because I have 5 slots left. And the maximum generated so far is equal to 8. And we wanted a k of 3. It changed here, and then it changed here. So what should be the remaining value of k? Can you tell me that? What will be the remaining value of k by the time we have generated all these values? It'll be 1, right? Because to start with, the k was 3. We wanted to ensure 3 as our search cost. And because we already got a 2 here, so 3 minus 1, 2. So now left over is 2. We got an 8 here, so 2 minus 1 is 1, so now left over is 1. Here it did not change, so now it became 1. So basically the idea is that there are 3 important variables for us, which are n, I'll make it a little small for understanding sake, max so far, and k, which is the remaining search cost that we have to ensure. How many of you are absolutely clear with all these 3 variables and what do they really mean? Oh, you thought the same approach? That's amazing. That's very good. Others? You understand what these variables are? Now, the next thing that we have to do is, see, if you were there in yesterday's live class, I told you that there is something called as elements of choice. Do you remember that? How many of you remember this term? Elements of choice is nothing. It means that how many choices do we have at any moment. So like in this question, we can say that at any moment we have m choices, because the next element could be anything in between 1 to m, in between 1 to 10, right? Okay, now that we know this thing, elements of choice, so we can now write a recurrence relation. A recurrence relation which makes lots and lots of sense. But before that, because I have 3 variables over here, I will tell you that this is a 3-dimensional DP. What is the meaning of dimension? The meaning of dimension is the variables that change as you make choices, as you make different choices, right? So you have n, max, and k. So I would say that I would define something called as answer of n, max, k, and I would define it in a certain way. It's just a definition, no need to fear from it. In fact, I must have defined it somewhere. Yeah, here it is. So let's read it, what's written here. Answer of n max k is equal to number of ways if we need a sequence of size n with search cost k, and the maximum value placed thus far or so far is max. So this is how my answer of n max k is defined. For example, if you take these things, okay, if you take these things here and if you feed them in here, n is 11, max is 10, and let's say, I'll just give you an example. Let's say to start with, max is 0, and let's say the value of k is 3. So what will be the meaning of this thing? Let's try to understand the meaning of this thing. The meaning of this thing is number of ways if we need a sequence of size 11. Do we need a sequence of size 11? Yes. Number of ways if we need a sequence of size 11, ensuring the search cost of 3 and the maximum value placed thus far is 0. So this is what should be the overall answer to this question, isn't it? Right? Because when you say you want to generate sequence of size 11, and to start with you have not placed anything, you have not placed any element, in that case you can say that the maximum value that you have generated so far is 0, and the search cost that you have to ensure is 3, and you have 11 leftovers, right? So this is how my answer of n max k is defined, right? Now, how should it change? How should it change with time? That is the most important question. Is it clear? How many of you are clear with this particular definition? Can say yes if you are. Yeah, okay. So yeah, if you have to decide your first element out of all the 11 elements, can you tell me how many choices you have? Just go on, tell me. The value of m is 10, so you have 10 choices. It could either be 1, right? Or it could be 2, right? Or it could be starting with 3, and so on and on. This is how it goes. This is how it goes on and on. And your final choice would have been something that starts with 10, right? Okay, now let me ask you one question. Can I say all the sequences which belong to this family will be different than the sequences that belong to this family and this family and that family? The answer is yes. There will be no overlap, because a sequence starting with 1 will never be same as a sequence that starts with 2 or starts with 3 or starts with 10, right? So if I know that how many valid sequences are there in this family which starts with 1, in this family which starts with 2, in this family which starts with 3, 4, 5, 6, 7, 8, 9 and 10, then what will be my overall answer? If I know the individual answers for all these families, what will be my overall answer? Do not hesitate to say that it will simply be the sum of all of them. Correct? because total number of sequences is equal to total number of sequences in this family plus that family plus that family, and so on and on and on, right? So we can eventually just sum everything up, and that will be our answer, and then the job will be done. As easy as that, correct? Okay, now the important question is that, hey, you had 3 states with you, not states, I'll call them variables. There were 11, which denoted your leftover size, 0, which denoted the maximum element so far, and 3, which denoted the search cost that we wanted to ensure. Now, when you have moved on to this particular transition, if you have placed a 1 over here, can you tell me the next set of values of these triplets? What is the leftover size? If you have already placed an element, the leftover size will be 10, correct? Now, because you placed a 1 here and your previous maximum was 0, what will be your next maximum? It will be 1. And because you placed an item which is greater than the current maximum, this thing will change. So now you'd say that, hey, I have already ensured 1 unit of search cost here. So now I just have to ensure 2 unit of search cost in the remaining part. Correct? Okay. Similarly, if guys you would have made the other transition, which is, let's say, this transition, what would be this triplet in this case? So of course, you place an item as the first item, so your leftovers are 10. And now because you placed a 2 here, so now your maximum will be how much? It will be 2. And what will be the value of k? So here, because of a new element, your maximum changed, so now it will be 2. Similarly, if you talk about the other one, what would it be? It would be 10, 3, 2. So do you see how these variables are changing as you are making different choices? How many of you have a very deep clarity in this thing? Yeah? Awesome. Now, the next thing that I want you guys to understand is that, hey, here it was so simple, it was super simple, because we were placing just the first element and the max so far was 0. So every time we were placing, the max was getting updated to whatever we have placed, and the value of k was becoming k minus 1. But would it be like that everywhere else also? So let's talk about the situation that arose for this. So I'm just going to ask you to focus your attention on this case where you placed a 3. When you placed a 3, your variables changed in this manner. And you understand why they changed like that. Tell me how many choices do you have for the next element? If the value of m is 10, how many choices do you have for the next element? Again, you have 10 choices, right? It could be 1, it could be 2, it could be 3, it could be 4, it could be anything in between 1 to 10. So let's say you go ahead and make your first choice. In the first choice, what you will do is you will have 3, 1, and then you don't know what. In the second choice, you will have 3, 2, and then you don't know what. And in the next choice, you will have 3, 3, and then you would also have 3, 4. So on and on and on. The last thing that you will have will be 3, 10. Correct? Now comes the important question. Let's say you decide to make this transition. If you decide to make this transition, how will these triplets change? How will it change? See, changing this is super simple because you put one more element, so now the leftover size is 9. Will your max change? No, because whatever you have placed is smaller than your previous max, smaller than or equal to your previous max. So your max will continue to be whatever it was. And because your max has not changed, so your k will also not change. Your k will also remain the way it is. Is it making sense? For how many of you it is making sense? Similarly, if you talk about this part also, the leftover size is 9, and because you haven't put anything which is greater than the previous max of 3, so the max so far will continue to be 3 and the other thing will also not change. But let's directly jump on to this transition. Can you guys quickly write the triplet for this transition? Oh, of course the first thing will be 9, but what will the second thing be? The second thing will be 4, because now it happens to be greater than max so far. So it will be 4, right? And what will the third thing be? Because you added an element 4 which is greater than the max so far, so you have reduced the remaining value of k, so now it will be 1. So the point to understand, guys, is that if you are placing elements like 1, 2, 3 which are smaller than equal to 3, which are smaller than equal to your max so far, in that case these two variables are not going to change. Only and only your leftover size is going to change. But if you are placing an element like 4, 5, 6, 7, 8, 9, 10 which are greater than your max so far, in that case your this though is changing only, your n is changing only, but now your max will become equal to whatever you have placed, and the third thing will be reduced by 1 unit because your max is getting updated there. How many of you feel absolutely clear with all these transitions that we have talked about? Does it make sense so far? Okay, if it makes sense so far, then the code to it is also super simple to understand. I'll show you the code. Okay, I'll directly show you the code and you can try correlating with it quickly. Don't worry about time limit exceeded. Okay, I'll tell you why the time limit got exceeded. Just look at the code for now. So as I told you, we have a function func. I have written a function func. In this function func, what we are doing is we are passing the value of n, which is the initial value. The current max, to start with, the current max will be 0, and that is what I have passed. Okay, and I have also passed the value of k, and I have also passed the value of m. This m is never going to change, but because in this function I need to refer to how many choices we have, so I have passed it over here. So basically I have written a separate function which is taking these 3 super important variables, and along with that it is also taking m, which is our input. Is it making sense? How many of you are clear with the parameters of this function? Yes or no? Yeah? Okay. Great. Now, moving on. Do not look at this part, okay? Forget about it. Imagine it does not exist. This is termination condition. I'll come to it, but forget about it for now. Just look at the remaining part. I told you one thing very clearly, that hey, whenever you put an element, let's say you decide to put a 1, you decide to put a 2, you decide to put a 3, decide to put a 4 as the first element, then you are going to get different number of solutions. So let's say the number of sequences you are getting from here is x, the number of sequences from here is y, the number of sequences from here is z, and so on and on. Then your overall answer is the sum of all of those. So if you are making, let's say, m different function calls, which you will be making, because you are saying that at each stage you have m choices. So if you are making m different function calls, you will be returned with m different values. And finally you have to sum them up, and that sum will be your answer. If you have understood this part, and if you have done little bit of recursion also, then this code should not be very hard to follow. So just look at it, what I have done. I have initialized a variable answer equals to 0, and now to start with, what I am doing is I am making a choice of considering next element which is smaller than or equal to my current maximum. You see, this loop is running from maximum to 1 in reverse direction. So here I am choosing my next element as something which is in between 1 to maximum, right? So this case is something like that, where you choose your next element as 1, 2 and 3. What is 1, 2 and 3? They are the values in between 1 to current max. And that is what I have done here. They are the values in between 1 to current max. Now I told you very clearly that whenever you do something like this, in that case, what happens? Of course your n changes because your leftover elements have reduced as you have chosen an element. And in this case, what happens is that your value of k does not change. Your value of max does not change. Why? I have answered it already. Because if you put an element which is smaller than your current max, your max does not update. And because of that, your search cost does not update. So you can see in this case what I have done is I have changed my n to n minus 1, but my maximum is exactly as that and my k is also exactly as that. Now tell me, now are you able to follow this particular for loop? As in what it does and why it does? Yes or no? Yeah. Okay. So this was for the case where our next element happened to be smaller than or equal to current maximum. Now look at this. In this part, what we are doing is we are considering our next element as something which is greater than maximum. So if you remember this, if our current maximum was 3, we could have 4, we could have 5, we could have 6, 7, 8, 9, 10. So anything in between max plus 1 to m, if I go with that, then my current maximum will change. In fact, my current maximum will be equal to whatever I have placed. And because of that, the remaining value of k will be k minus 1. So what I am doing is I am making these function calls, and I am adding their values to an answer variable, and I am finally returning that. This is the gist of whatever activity I did here. So look at it again and tell me if you are able to correlate. You can say a quick yes if you are really able to correlate. Yeah. Okay. Now you might be wondering that, hey, what about the termination condition? We have to think of the termination condition also, right? So let's think of it. See guys, as you are placing the elements, the value of k constantly goes on changing. For example, when you chose your first element as 3, the value of k became how much? Tell me. 2. Now when you chose your next element as 4, the value of k became 1. Let's say you chose your next element as 5. What will be the value of k now? 0. So far so good. If you choose your next element as 6, what will be the value of k now? Minus 1. What does it mean? It means that in the remaining part, you want to put some elements so that the search cost is -1. Tell me guys, can you ever generate a search cost of -1? Is it ever possible to get a search cost of -1? Is it even real world? Is it even sensible? The answer is no. So if it ever happens that k becomes negative, we can immediately return 0. Why return 0? Because there is no way I can produce a subsequence that gives me -1 as the search cost, because there are no ways. I can say there are 0 ways, so I am returning 0. Is it clear why this is one of the termination conditions that we really needed? Yes or no? Yeah. Okay. One more termination condition. That termination condition would happen for happy cases. What I mean by happy cases is something like this. So if you remember something like this, let's say if you had run your logic to generate this kind of sequence, eventually what would be the value of n? After you have placed all the 11 elements, finally what would be the value of n? It would be 0. And what would be the value of k? That would also be 0. So this is a happy case for me. So if n is 0 and k is 0, what does it mean? It means that, hey, I have no leftover. So I have empty leftover space and I want 0 as the search cost. So how many ways are there? I would say there is only one way, because if you want to generate an empty sequence, there is only one empty sequence. That's it. This is an empty sequence. And in this empty sequence, what is the search cost? The search cost will be 0 because there will be no iterations only. Correct? So this is my happy case, which I have written in this way, that if our n is 0 and along with that k is also 0, I would want to return 1. But let me tell you one thing. What if you rather had generated something like this? Let's say you had generated this kind of sequence. In this case, what would have been your eventual value of n? Because you have already populated all the 11 elements, the eventual value of n would be 0. And can you tell me the eventual value of k? What would it be? It would be 1, because your maximum got updated here and after that nowhere. So if it ever happens that you are out of elements but you have not generated the desired search cost, in that case you should return 0. It makes sense to return 0 in that case, isn't it? Because n equals to 0 means that, hey, you have empty. You have nothing with you. And now you somehow want to ensure a search cost of 1. If there is nothing to search, what the hell is search cost? So there are no way to do that. If there are no way to do that, there are 0 ways to do that. So we return 0 over here. So these are the termination conditions which will be backing this recurrence relation. Is it clear? How many of you could follow me on this part? So far the code that we have written is perfectly correct code, and it's nothing but recursion. It's flat recursion. But as you can see, there are so many function calls that are happening. So the time complexity of this will be exponential. And in fact, we will also see things like, overlapping subproblems. We don't need to explicitly handle cases when case, you can refactor that. It's up to you. Okay. I have not taken care of removing redundancies from here. If you feel you can do that, awesome. Go ahead and please do that. Okay. But the core idea is clear to all, right? Yeah, coming back to the point, here this particular logic will give you time limit exceeded, which I have also gotten. And the reason behind that is very simple, that there will be so many function calls, and as a consequence of that, you will have overlapping subproblems and the complexity will be exponential. Now, if you ask me, explain me overlapping subproblems, I can't do that in this short class. That's a core concept of DP, and if you guys please take some time out to watch those videos which were handed over to you by Kritika, that will do you a lot of favor. You'll understand a lot from there. But anyways, yeah. So, there are two things that I have to fix here. The first thing that, hey, here I am nowhere handling overflow case, because the question clearly says that you have to return answer modulo this value, because your answer can be very large. Your answer can be very large. So what does the rule of modular arithmetic says? How many of you do not know anything about modular arithmetic? Can you just say yes if you do not know anything about modular arithmetic? It's an arithmetic of remainders, and it's something that you should know. So it says that a plus b modulus of m is equals to a mod m plus b mod m whole mod m. Now if you're wondering why I'm telling you this thing, I'm telling you this thing because throughout the process what you are doing is you are doing some additions. This line is same as addition of two integers. And now you do not have to just return the answer, you have to return answer mod m. So you have to constantly keep on taking mod m. And if you want to constantly keep on taking mod m, this is the rule that you have to follow. Okay, do you get this point? So basically the changes that will happen is if I click on this edit code and if it comes here, the changes from modular arithmetic perspective will be, the first change will say that answer is equals to answer mod m, and I'll have to pass this m. This is not that m, it's the mod value, which is 10 power 9 plus 7, which is given to you as input, plus the other thing mod this whole mod that. Okay, and the exact same thing needs to be done here also. Answer equals to answer mod plus the other thing mod and then whole mod. So this is something that I am required to do. This is just for taking case of modular arithmetic part, which is there in this question because the answer can be very large. The second thing is how to introduce DP, memoization. So this question is a three-dimensional DP. Because it's a three-dimensional DP, I need 3 dimensions. I need a 3-dimensional array, or I need a 3-dimensional vector. So I would need a 3-dimensional vector where the first dimension will denote the size of leftover space, and my leftover space at max could be of size n. So I can have my first dimension as n plus 1 in the 3D array. The second dimension that I can have can be of size m plus 1 because the maximum element that I ever generate will not be greater than m. And the third dimension can be k plus 1. So I'll declare a 3D array or a 3D vector, and I'll initialize every item to -1 to begin with. So if I show you my pre-written code for that, I wrote code before because I knew that it'll take a lot of time for me to explain you the logic, and I did not want to waste time in writing the code rather than explaining it. So you can see that the first line here is to create a vector of vector called as answer. The first dimension is of size n plus 1, which I told you. The second dimension is of size m plus 1, and the third dimension is of size k plus 1. This is pure memoization, which is a basic concept of DP. I initialized everything to -1 initially, and then I passed this answer by reference. Make sure to pass it by reference. If you do not pass it by reference, for every function call, this huge data structure will be copied again and again, and you will get a time limit exceeded, even though you are using DP. So pass it by reference, and also pass your this mod value over here. The key things over here to track are n, max, and k, as we all know. This remains as it is. And now if you remember yesterday's class, when we use memoization, we want to ensure that if we have solved a problem, we do not solve it again. And if you remember, we had initialized everything as -1. So if we ever see that for a given triplet, the answer is not equals to -1, it means that this particular state has been encountered and this particular problem has been solved. So we are seeing it again. If we are seeing it again, we don't need to solve it again, we just return the answer that we had memoized before. Otherwise, what we do is simple trivial logic. We initialize a value as 0, and then in this loop, we are making a choice of putting element which are smaller than equal to max, and in that case you can see that only n is changing. It becomes n minus 1. Max and k do not change. And this is the loop where we make a choice to put greater values. Here you can see that n also changes, and as discussed, these two values also change. Finally, once we have gathered the answer for n max k for this particular unique triplet, we store it inside our memoization 3D array, and then we return that 3D array. That's all. Okay. Okay, great. Food for thought for you guys after this class is that when you guys go back, just give some time to think about what will be the time complexity of it. I would really love to talk about it if I ever get to discuss DP in some other class. I'll give you some idea of what it looks like. But could you guys relate on the, I know it was a hard question. It was really hard question. Even the people who are very well versed with DSA might not be able to get it right in the first go. But were you able to enjoy and understand the intricacies of the problem? Could you understand how elements of choices were being made and how the different transitions were happening, and in fact, how we wrote our super simple recursive code, and then we went on to put DP layer on top of that. So that's the most important thing, right? Okay then, great. So I think that will be it for today. Just go back, revise these things, and see you all again in the next class. Bye and good night.